This is for IBSL and HL chemistry, looking at organic chemistry, structural isomers, identifying and naming structural isomers. Structural isomers have the same molecular formula, but different arrangements of atoms. I could define isomerism by saying isomers have the same molecular formula, but have different structures. There are 3 structural isomers of pentane. I begin on the left with my first diagram showing the 5 carbons in a straight chain. That leads to a skeletal structure of pentane. From there, I'll reduce the number of carbons in the straight chain by 1 and go to methyl butane. No need to say 2-methyl butane. There's only one place for the side chain to be, although 2-methyl butane is not incorrect. 3 carbons in a straight chain, propane. I've got 2 more carbons to place, dimethyl propane. If we go in order, with the longest chain first, and gradually lowering the number of carbon atoms in the chain, then we can be sure there was nothing omitted. And if we name the structures, we can be sure that there are no repeats. If 2 structures drawn have the same name, then a structure has been repeated. That is your check. Favorite IB style question: how many isomers are there of hexane? So I begin with the skeletal formula of my straight chain of the 6 carbons present in hexane. From there, 5 carbons in a straight chain, pentane. I've got a 6th carbon to place as a side chain, 2-methyl pentane, and I could have 3-methyl pentane. No more possibilities for a straight chain of 5. I move to 4. 2 more carbons to place as side chains, 2,3-dimethyl butane or 2,2-dimethyl butane. Drawing and naming the isomers in order helps us to be sure that there are 5 isomers and no repeats. Positional isomers indicate different positions of a functional group. For butanol, I've got my 4 carbons in a straight chain to begin with my OH on carbon number 1. This is butanol, primary alcohol, often represented by 1 with the superscript. Carbon bonded to the OH is bonded to 1 other carbon atom. That's what makes it primary. Butanol is a secondary alcohol, often represented by a 2 with the superscript. The carbon bonded to the OH is now bonded to 2 other carbon atoms. No more possibilities with a straight chain of 4, we move to a straight chain of 3. If I've got a straight chain of 3, then I'm really dealing with a structure based on methyl propane. My OH could go on carbon number 2 to give me 2-methyl propan 2-ol. This is tertiary. The carbon bearing the functional group, the OH, is bonded to 3 other carbons. One more possibility, I think easy to miss, but I could have 2-methyl propan 1-ol. My OH group on one of the ends of the chain, but I'm still basing my structure on methyl propane. 2-methyl propan 1-ol is primary. Carbon with the OH is bonded to 1 more carbon atom. It's the same for halogenoalkanes. For chlorobutane, my chlorine could be on the end of the chain of 4, making it primary. The carbon with the Cl is bonded to 1 carbon. I could make it 2-chlorobutane. The carbon bonded to the halogen is bonded to 2 other carbon atoms. I'm done with a chain of 4. Let's go to 3. 2-chloro, 2-methylpropane is tertiary, represented by 3, with the degree sign if you like. And I could have 1-chloro, 2-methylpropane. Easy to miss that one. But if I go with my straight chain of 3, include the methyl group as I must, I could have the Cl in 2 places. Positional isomers of alcohols and halogenoalkanes have different properties. Examples. And we'll cover these two in a lot more detail on specialist presentations on the 2 different functional groups. The mechanism for nucleophilic substitution is SN2. For primary halogenoalkanes, it's SN1 for tertiary halogenoalkanes. Oxidation of primary alcohol gives an aldehyde. Oxidation of secondary alcohols gives a ketone. Tertiary alcohols do not oxidize. Again, more detail on that. I'll be doing a separate presentation on alcohols and halogenoalkanes. Amines. The R group indicates a carbon atom or chain. But the amines also form isomers, although with amines, the difference is with the number of hydrogen atoms bonded to the nitrogen. Based on ammonia, NH3, I can have primary amine, where the nitrogen is bonded to 1 carbon, methylamine, methylamine. I can have a secondary amine. Here I've got 2 ethyl groups bonded to the nitrogen. Diethylamine. Or a tertiary. 3 methyl groups bonded to the central nitrogen, trimethylamine. Propanal, with my oxygen on the end of a chain, and propanone, with it in the middle of a chain, have the same chemical formula, C2H6O, and they have similar bonding but different structures. They have different functional groups and so react differently. The aldehyde can be oxidized, but the ketone cannot. Here's my aldehyde, C double bond O on the end. Here's my ketone, C double bond O in the middle of the chain. Only 3 isomers of dibromobenzene. Small point. This supports the current model of benzene structure. Benzene has the formula C6H6. It was long thought to have alternating single and double bonds as shown, a ring structure. If the above was the true structure, there would be many possible structures for dibromobenzene. The currently accepted model of benzene has a delocalized ring of electrons in the ring of 6 carbon atoms. Here, there are only 3 possible structures for dibromobenzene, which is consistent with observations, favoring the structure with the delocalized ring. Just to say, if the first bromine was in position 1, then the second could be in positions 2, 3, or 4. Finally, and I kind of promised it, how many isomers have the formula C6H14? If you were confronted with that in an exam, you might start writing them down randomly. How would you know when you've got them all? Very hard thing to do confidently. Start with the longest chain. Hexane, chain of 6. Move to the second possible longest chain, pentane. Chain of 5, I've got the methyl group to account for also. I can put it in position 2 for 2-methylpentane, or position 3 for 3-methylpentane. Done with the chain of 5. Move to 4. 4 in a chain, I can have my 2 methyl groups on position 2. 2,2-dimethylbutane, I can have them in positions 2 and 3 2,3-dimethylbutane. That's it. If you got something out of that, please hit the like button, subscribe to be informed about more videos coming out.